This is the solution video for section 8.1, problem number 9. All right, so it says set up an expression that involves at most two integrals that represents the area bounded by the curves y equals x plus 3 and x equals negative y squared plus 3. All right, so we have two graphs here. We have to come up with what the curves look like. And then part A says use a dx cut, and part B says use a dy cut. All right, so first of all, y equals x plus 3. All right, we should know that is a line with a slope of 1 and a y-intercept of 3. All right, so let's go ahead and draw that. All right, so I have a line, slope of 1, y-intercept of 3, so something like that. All right. Next, I have x equals negative y squared plus 3. All right, so what is that? Well, that's actually a sideways parabola facing to the left because we have the negative coefficient of y squared, and then we have this plus 3. So what does that do? Well, that shifts it to the right 3. All right, but if you're not sure or whatever, right, you could always plug in some numbers to determine. So how would I plug in a number to figure out like where that is? Has it been shifted to the left or to the right or whatever, right? Well, this is when y is 0, right? So if y is 0 and we add 3 to it, x is 3, right? So this is 3 comma 0, right? So that's pretty easy to do that, right? All right, so now we need to know these 2 points of intersection. So I have to have some method of solving those, right? So what I'm going to do is I'm going to take x out of the first equation and put what x is equal to into that equation. So I get that y is equal to negative y squared plus 3 plus 3. All right, everyone okay with that? All right, so I get y equals, the parentheses don't really do anything for me, so negative y squared plus 6. All right, so now I'm going to add y squared, or sorry, I'm not going to add y squared. I am going to add y squared, but I'm going to get everything on one side, so I get y squared plus y minus 6 equals 0, and so now I'm going to factor y plus 3 and y minus 2. So y equals negative 3 and y equals positive 2, right? So remember, what have I just found? I've found the y values of those points of intersection, right? So this intersection is something comma negative 3, and this intersection is something comma 2. All right, so now I also want to know the x values, right? So y is x plus 3, right? Or x is negative y squared plus 3. So let's figure out x. X is negative y squared. Sorry, let me rewrite that. All right, negative y, so 2 squared plus 3. All right, so negative 2 squared, so 4. Negative 4 plus 3 is negative 1, right? So this is negative 1, which actually means that my drawing is kind of bad. It should be like over here somewhere, but oh well. All right, so I get negative 1. All right, then here x equals negative, and then negative 3 squared plus 3. So negative 3 squared, right, is positive 9, but make it negative. So negative 9 plus 3 is negative 6, right? So this x value is negative 6. All right, so now part A, all right, it says to use a dx cut. All right, so that means I should realize that I have this portion over here using a dx, and then this portion over here. So I'm actually going to need two separate integrals. All right, so let's start with the region on the left. All right, so remember, if I'm using a dx, that means both equations need to be in y equals form. So the first one is y equals x plus 3, but the second one is not, so I need to solve for y. So I'm going to add y squared, subtract x, and square root. So y equals plus or minus the square root of negative x plus 3. All right? And so I get the top half of the curve is the positive root negative x plus 3, and the bottom half is the negative root negative x plus 3. All right. So now, all right, let's do the region on the left. So I have the integral of something with respect to x. All right, so what is the something? All right, so the region on the left, I'm going to take the line, which is the upper boundary, so that's going to be x plus 3, minus the lower boundary. What's the lower boundary? Well, it's actually the negative root negative x plus 3. All right, and then we're going to integrate from left to right. So the integral from left, negative 6, to right is negative 1. Remember, you're using x values. All right, and then plus the second integral, the area on the right here. All right, so I'm going to integrate something with respect to x. All right, so now I'm going to take the upper boundary of the region, which is the positive root negative x plus 3, minus the lower boundary, which is the negative root negative x plus 3. Okay, and I'm going to integrate from what to what. So now I'm integrating from -1 all the way to the right to 3. All right, and so the sum of those two integrals is part A. Now, what you do want to realize is if I'm subtracting a negative up here, all right, it's really just x plus 3 plus the root of negative x plus 3. All right, and then here I take the root of negative x plus 3 plus the root of negative x plus 3. So this is actually just 2 root negative x plus 3. All right, so I think the answer sheet has that version simplified there. All right, but now let's go ahead and do part B. All right, part B says use a dy cut. All right, so now I'm going to tilt my head to the side, right, and I'm going to draw a horizontal rectangle. All right, so this is my dy. All right, and so now we're going to integrate something with respect to y. All right, so just a reminder, if I'm integrating with respect to y, I need to have equations that are in x equals form. So the first one would need to be rewritten as x equals let's see, y minus 3, right? And the other one was originally in x equals form, x equals negative y squared plus 3. All right, so now if I tilt my head to the right, what is the upper boundary or the right-hand boundary of the dy? It's the parabola, right? So we're going to take the negative y squared plus 3, and we're going to subtract the lower boundary, which is the y minus 3. So keep in mind, you must have only y's. You have to have x equals equations written in there. All right, and now I look at the lower boundary, okay, the -3. Remember, we're integrating with y values here, so -3 all the way up to 2. All right, so that is part B.